Okay, we shall now talk about cumulative probability distribution function, and this is denoted by capital Fx. And also this is called the distribution function. So distribution function, unless otherwise stated, this is the cumulative probability distribution function. Cumulative probability distribution function is just like you add up the probability one by one up to the given extent, but not as a whole at that time. Maybe may or may not be the whole probability. So cumulative means you keep on adding probability within the given range of values for the defined range of values of x. You can see here fx equal to p, x is less or equal to x. So for example, in this figure, your density function is defined for x between 0 and 4, including maybe inclusive. In that case, for example, if you would like to add up the probability from, say it is 1, so if you are within this 0 to 4, if you are adding a probability from 0 to 1 only, and then you develop a kind of general function, then that will be called the probability, the cumulative probability distribution function. It is also possible that not from 0 to 1 only, maybe 0 to 2, we can integrate the function, and then that means we have been adding the area from 0 to 2. And then in general you can say this is on the x-axis it is x for example, or t for example. So if you integrate the area of the given curve under the range of value of x from 0 to x, and then you'll have new function develop, and that sort of function is called the cumulative probability density function. So maximum value of cumulative probability distribution function will be 1, that is the total probability, and all the sort of work we do within the probability 1. This is like cumulative frequency, as in frequency distribution table. And here is one example given here, that x is a continuous random variable with PDF as shown here. So probability density function is fx equal to 1 by 8 times of x, and this graph is for the function fx equal to 1 by 8 times of x. And now find the cumulative distribution function at this case y equal to fx. So first of all, from this probability density function, we have to find the cumulative distribution function, and then we have to sketch the curve, and then we have to see the difference between those two curves here. So here ft means, in general, t, I am taking any value t between 0 and 4 in this case. For example, t ft equal to, you can write 1 by 8 x dx. It's okay. Ft, that means we integrate the given function 1 by 8 in the range of value of x, or in the range of value of t from 0 to t here, just like saying 0 to 1 and 0 to 2. So in general we can say this is 0 to t. After integration, so 8 is constant, it is taken outside, and then integration of the x is x squared by 2, and from 0 to t, and after putting back this range of value of for t here in this function, so you can write this is t squared by 18. So this is the new function now. So as we are, our function is given in terms of x, so we replace t by x, and then the situation will be like this. Then capital Fx is 0 for less or equals to 0. Why it is? Because less or equal to 0, if you are talking, although mathematically this curve has the part below the 0, but statistically it says that this function is defined between 0 to 4 only. So any probability below 0 will be 0. That means we are integrating 0. Between 0 and x in general, between 0 and 4 in general, it is x squared by 16 that we have taken from here. What about bigger than that? So at this point it attains the highest probability. So if you integrate from 0 to 4 itself, the total area has been covered. So total height will be here up to fx. If you talk about, this is 1, and after that, even if you consider the value greater than 4, in that case, although the curve has path like this, but the total probability cannot exceed 1 because of the definition of the probability. Therefore, instead of considering this part of the curve, all the values after x greater or equal to 4 will be equal to 1, and this is the reason why there is a straight line after this. This is the way that how we obtain cumulative distribution function from the given probability density function. So this part is most important to understand.